Today, let me show you how the data looks like taken from our different sensors. Remember, we have three sensors. One is the HT22 that records temperature and humidity. Another one is carbon monoxide sensor, and the last sensor is PM 2.5 sensor. So I have here all the data taken from the cloud server, and we will try to clean, organize, and analyze the data. So our sensor is labeled accordingly. We have here TICA 01, that's the name of the sensor, and the date of the data taken from that sensor. So we have 2023 is the year, 04 is the month, which is April, and 12 is the day. So let me go ahead and show to you how the data looks like. Let's try this TICA 01 2023 04 10. To start cleaning the data of your sensor, your data must be converted into a format of .csv in order for you to be able to read that using spreadsheets like Excel or Google Sheet. So I will open that data, this data that says .csv, and open with Google Sheets, and this is how your data from the sensors look like. So we have here the time and date for the sensors. Reading, we have the temperature reading in degrees Celsius, humidity in percent, that is our relative humidity. We have the carbon monoxide sensor in the unit of parts per million, the timestamp of every reading, PM1, PM2.5, and PM10 in microgram per cubic meter. So this is how the data looks like after you extracted that from the cloud. And we will try to make a copy of this data so that we can play around and try to organize and analyze the data. So let me go ahead and copy the data to my existing worksheet or spreadsheet, and you can choose if you want to create a new spreadsheet, but I do have already one, so I will just place it under TICA 01 as another sheet, so it will be copied as another sheet. So I will go to TICA 01 drive, and if you notice, I have here copy of TICA 01 dot 2023 0410. So let me just rename it into TICA 01. So I just removed the copy and then adjusted it accordingly. So I have 10, 12, 13. I still have the 11th, but I didn't include that yet. So we can go ahead and clean the data of our sensors. And by cleaning, we're gonna have to look into errors or noise on the data. So you can scroll down manually and see if there are like no values or errors on the sensor readings. Normally, for the errors, it comes out if the sensor is damaged. So that means there will be no data readings, or there will be a blank space for that reading. Another one factor is also power outage. So if there's no power supply connected to it, or there's a problem on the power supply, then definitely the sensor will not work. And the other one is the internet connectivity. So if there's no internet connectivity to the sensor, then that might also cause an error on the readings of the sensor. So I have here all the data. It seems that it has no error, and the noise is not found. So I'm gonna go ahead and organize this data. How to organize the data? You can organize the data by making a tabular representation or a chart representation. So let me try putting this data into a chart. So I will highlight the things that I will be needing. So if I'm going to graph or put the data into graphical representation, you can just highlight the elements that you need or the columns that you need. So I have highlighted the time, the temperature, humidity, carbon monoxide, and the PM data. Once you highlighted all that data, you can go ahead and click on Insert. And on the Insert, you have there the options. You can click on Chart, and from that it will automatically make the chart for you. If you notice, you have here the temperature, humidity, carbon monoxide, PM1, PM2.5, etc. You can change that title if you want. You can go to customize. You can also change the type of a graph that you are using. So you have here different type of chart available for you. You have here the legend, and if you want to make changes to your chart, you can go and click on customize, or you can even do aggregate. When we say aggregate, we want to spread out all this data. So whatever is on your x-axis right now and you click on aggregate, that means you're going to spread out or expand the data that you have. So all the time and date will be shown here, and you will have here the readings of your quality or quantity. So um, you have here, if you want to make it the average, then go ahead and click on average and it will show you your graph. If you want to make changes on your graph, you can go ahead and click on customize. So you can click on chart axis title. If you notice here, it says temperature, humidity, carbon monoxide. You could just say sensor data, or you could say TICA -01, and then you can change also everything that you want to change. Like you can put thread line, you can also put minimum and maximum values, and do some series or make some thread line. Probably you can show also some equations if you want to. So you can show the equations for each of the data that you have here. If you want to know what is the intrinsic correlation of each of the sensors that we had created with respect to the readings of each sensor. So that's how we do the organization. Um, if you want to graph them individually, you can go ahead and do the graphing. Say, for example, I want to graph the time and just the PM. So again, you can just highlight this and then the time and then click on insert and then chart, and then you will have just for the PM 1, PM 2.5, and PM 10. So you can make some adjustments. Say I want to aggregate this and I want to make some adjustment on the data. You can make it under average, and you can customize your chart by clicking customize and adjust everything possible on these labels. So you can do also this for temperature, humidity, and carbon monoxide. So that's how we organize the data. You can play around with your data. Now we will try to compare the data that we have taken from our IoT sensor to the standard City Airlink sensor that we have installed alongside with the IoT sensors that we made. Our City Airlink sensor, or the Davis sensor, measures the air quality specifically for PM1, 2.5, and 10, and also the humidity and the temperature of the place. We will try to compare the data readings of this standard sensor and to the data readings of our IoT sensor. Um, the data readings of our standard sensor is actually being timestamped in every 15 seconds interval, while on our data for IoT sensor, the reading is done every minute of the time. So we will try to make sure that when we compare the two sensors, we will have the same amount of time. And to do that, we will try to interpolate the data of our city air link so that it will match with the data readings of our sensor. In order for us to do the interpolation, we will try to go with making the time same with the data from both sensor. So I will insert another column here to the left, and I will copy the time format and paste that on this column. And this column will be changed into number so that we would be able to interpolate the data. Now, for us to be able to do that, we will try to use the interpolation for PM1, PM2.5, PM10. Let's say I will work on PM1, PM2.5, and PM10. I had already prepared the data um, and the formula, so I will just copy the formula for this one, and then I will try to paste this formula into this TICA sensor 7. So I have here the interpolated value for PM1. So I will label it PM1 interpolated. So the function of interpolation is for us to be able to have the same data and at the same time for each of those sensors, because then again the time difference of the two sensors is huge, so we're gonna have to make sure that they will be having the same time. And this is the value for PM1, which is interpolated for the same time. So we have PM2.5, and we'll do the interpolation for PM2.5. So I will also copy the same formula for PM2.5, and then let me go ahead and do the interpolation and double click, and it will run down all the data. So this is PM2.5 interpolated. This is also one way of organizing your data. The very reason why we need to compare that in order for us to be able to know if there are errors and um, uh, issues on inaccuracy of the data. So we will be able to resolve the issues on reliability and accuracy of the data readings from our made sensors. So we will have the last one for the interpolated PM2.10. So you can go ahead and play around with the data and also do the interpolation by yourself by using the interpolated function. So we use forecast, match, and index formula to be able to interpolate PM1, PM2.5, and PM10. So there you go. You have now the PM1, PM2.5, and PM10. Now, if we are going to look into the correlation value of each sensor, say I want to know if the correlation value of City Erlink and our IoT sensor is right or has a good correlation, and we can solve for the correlation using the formula for correlation. So I already solved for the correlation for other sensors, so let me just use the formula and then put that correlation value. So we will try to know how many columns do we have for cell value. We have 4,642 data counts, so 4642 data counts, 4642. So we will try to compare the IoT and the interpolated PM2.5 of value. The interpolated 2.5 or interpolated PM values are values coming from the Davis or standard sensor. So let's say 0.4642. And let's see here what is the correlation value that we got. So we have 0.24 correlation value. So we will try to copy the same formula, but this time we will apply this to PM 2.5, and it should be H, and that this should be K2 and K. All right, so it says error H2 and K2. All right, so you have here 0.4, and the last one is for the PM10. So we will have PM10 is I4, I2, and then we will have 6462. We have here the I and L2 and L2 and enter. So this is the correlation between the two sensors. So the higher the correlation, that means your sensor, your IoT sensor and your city Link or the standard sensor, if there's a high correlation, that means that your sensor is working fine, working accurately, or reading the data accurately. So as of the moment, we have below 50%, but it's a positive correlation and it's still good. So this sensor is actually reading very well, but it needs some tuning on the sensor per se. So we will try to look into that sensor and analyze further so that we will be able to see if there's an increase in correlation. So that's how we do the correlation. Now, if you're going to graph that correlation value, then we can do the graphing techniques that I taught you a while ago. And you can compare, see if you want to graph the interpolated value of the PM in terms of the time. So let's say I will graph the time and the interpolated values. I will go and click on insert and then click on chart, and I will be using a scatter plot, and with that I will use aggregate. I will put this into average, and instead of this one being there, I will put remove and put remove. I will just put the x-axis to be t, and the series should be all this value from PM1 and PM10. So I have here the graph. If you want to adjust or make some adjustment, you can go ahead and click on the adjustment so you could see here how it looks like, and you can put the trend line for each. You can put also the equation if you want to include the correlation of each equation. You can also edit everything for your graph. So pretty much that's how you are going to graph your PM interpolated values.